Okay, so we have this applet up here. I want everyone to look on the board. And you have your paper flipped over to the back. Flip your eccentricity and directrix paper to the back. And we're going to create the different conic sections. So you see in the table, it says eccentricity E equals 0. So we're on this section of the back of our paper. So I have this slider B, and what I want you to be watching is the value for eccentricity. You guys see it off to the left here? Okay. So, and you see how it's changing as I slide B? So let's make eccentricity 0. Okay, what shape does it make? You might not be able to see it on here, but you guys remember this. What conic section has an eccentricity of 0? A circle. Good. So go back on your paper and write circle. Okay, so now let's go back, and we want the eccentricity. The next thing in our chart is between 0 and 1. So again, we're going to drag this, and you're watching your eccentricity right here. And right now it's a value between 0 and 1. And what kind of shape does it make? Good, it's an ellipse. So let's go back to our paper, and let's record that when the eccentricity is between 0 and 1, we have an ellipse. What happens when the eccentricity, again, watch right here, what happens when the eccentricity is exactly 1? Good, it's a parabola, so let's record that. And then what about when the eccentricity is over 1? Hyperbola, good. Let's go ahead and write that one. We know that one's a hyperbola. Okay, so up until now, we've defined eccentricity as C over A. But there is another definition for eccentricity. And what we're going to do is we're going to go back to the applet, and we're going to figure out what the definition is. So let's stick with parabolas. You guys studied these in Algebra 2. Do you remember when we talked about the focus and the directrix of a parabola? Does this sound familiar from Algebra 2? So in this picture, here's our parabola. The focus is right here. It's labeled with an F. Where is the focus of this parabola? It's at the origin. And for the purpose of what we're going to do today, we're going to keep the focus at the origin for every single figure we have. And then we have this line. And who remembers from Algebra 2 what that line is called? The directrix. Good. And so what I want you to remember, so we know the eccentricity is 1. I want you to watch these values over here. And I want you to think about how we might get that the eccentricity is 1 using these values. Point P is some point on the parabola. And I'm going to drag P, and I want you to watch the values off to the left as P moves. And I want you to think about how could we be calculating the eccentricity right now? What are the numbers that are changing? PD, and what else is changing? FP. So PD is the distance from the point to the directrix, and PF is the distance from the point to the focus. How do you think I might use those to get eccentricity? What's the eccentricity of this parabola? The eccentricity is 1, and notice that as I move P, the eccentricity stays 1. So FP over PV might be how we are defining eccentricity. So now let's go to a different shape. Let's make an ellipse. Okay, this ellipse has eccentricity 0.82. So I'm going to move P, focus on FP and PD. As I move the point P, how do you think I'm getting 0.82? It's a fraction of what? Yeah, let's double check that on calculators. Grab your calculator and do 1.71 over 2.09. And you get 0.818, which rounds to 0.82. What's the eccentricity of this ellipse? 0.82. Good. So the definition The new definition for eccentricity, can you write this, is going to be FP over PD. So this is a new definition for eccentricity. So the last piece on this paper is we're going to compare FP and PD. All right, let's start with the hyperbola off to the right. So if we have a hyperbola, what's the relationship between FP and PD? So here I have a hyperbola. You can look on the screen. There's a hyperbola. Compare FP to PD. Are they equal? Is one greater? Is one less than? Good. FP. So right here I want you to write that FP is greater than PD. What if we have a parabola? What's the relationship between FP and PD then? They're equal. Good. So let's write that they're equal. And then what about an ellipse? What's the relationship there? Good. PD is greater than FP, or we could also say FP is less than PD. Good. What do you think is going to be true for a circle? So a circle is just a special type of ellipse. So it will also be less than. FP will also be less than PD. Now in this one, you guys might remember I had trouble making a circle because, remind me again, where's the focus? It's on the origin. If you have a circle, your distance to your focus is 0 because its eccentricity is 0. So if I am 0 units away from the focus, I'm on the focus. So right now, when I tried to make a circle, it just sort of dissolved into a single point. So we actually can't look at circles the way this is set up right now. But this is this whole point. It says notice FP for the circle. Why is the distance from a point on the circle to the focus 0? Okay, it's because we put our focus on the origin. So we won't deal with circles today. We're going to leave those for another day.